Hello, good afternoon, everyone. I hope I'm audible and visible to everyone. Respected author and invited guests, welcome to the technical session 9E. Myself, Gayatri Burgura, and the session will be moderated by me. On behalf of Global Knowledge Research Foundation and GR Scholastic, it is my great pleasure to welcome you to the 10th International Conference on Smart Trends in Computing and Communications, that is SMARTCOM 2026, Pune, India. The 10th edition of the conference is being organized in a hybrid mode. The physical event is being held today in Pune, India, and the virtual event is being held through Zoom from 19th to 21st January
को भी अटैच करने की
2026.
जरूरत पड़ेगी क्या स्पीकर के लिए?
Sorry, ma'am.
I'm
I,
sorry.
I hope I hope you will enjoy the knowledgeable and interactive sessions throughout the day. In this session, we have 10 presentations. Each presenter will be given 10 minutes for the presentations and 2 minutes for the question and answers. Upon 9 minutes, I will raise a gentle reminder. There's a small request to all the participants that you all stay connected till the closing remarks. If you have any query or update, then you can write it to me in the chat box. Just before we start the session, I would like to introduce you all to the chair for this session, Dr. Archana Chaudhary. She is an assistant professor at Vishwakarma Institute of Technology, Pune, India. She has over 20 years of experience, including 4 years in the industry and more than 15 years in academia. She has published several researches, papers in international journals and conferences. She is also an IEEE member. Her research interests include signal image processing, Internet of Things, control system, and artificial intelligence and machine learning. Ma'am, would you like to address the participants?
Yes, thank you. I welcome all the participants of the conference, and I would like to wish them good luck for their. Thank you very much.
Yeah, thank you, ma'am. Thank you, ma'am. Now, I would like to finally start with the paper presentations. I would like to call upon our very first author, Vento ma'am, to present her paper titled A Comprehensive Analysis of Pre-Processing Strategies for Hindi Word Sense Disambiguation. Over to you, ma'am.
Good afternoon, everyone.
Yes, ma'am, you're
Ma'am.
audible. You can share your screen and start presenting.
Ma'am, please allow me to share my screen.
Yes, you can share now.
Thank you, ma'am. Is my screen visible?
Yes, ma'am, it's visible. You may start presenting now.
Okay, thank you. Thank you so much. First of all, good afternoon, everyone. My name is Vinto. I am a researcher at Department of Computer Science and Application, Punjab University, Chandigarh. I am doing my PhD under the guidance of Dr. Neeru Mago and Dr. Rajkumari ma'am. I am working in the area of natural language processing with a focus on Hindi word sense disambiguation. Today, I am presenting a paper on a comprehensive analysis of pre-processing strategies for Hindi word sense disambiguation. Thank you for the opportunity to present our work. Let me. Thank you. These are the table of contents that I'm going to explain in the upcoming presentation. First of all, introduction to word sense disambiguation. Word sense disambiguation is the process of determining which meaning of a word is used in a given context when the word has multiple meanings. For example, the Hindi word mang has different meanings depending on the sentence. In the first sentence, it means demand, and in the second sentence, it refers to the parting of the hair. WSD helps identify the correct meaning based on surrounding words and context. Word sense disambiguation plays an important role for resolving ambiguity in natural language, particularly in complex languages such as Hindi, which provide difficulty due to its rich linguistic structure. While WST is well studied in English, Hindi WST is still in its early stages but is gaining popularity due to the necessity for precise translation and information retrieval for over 650 million speakers. Creating a Hindi WST system is critical for handling large amounts of information in Hindi, especially in machine translation and text mining applications. These are the applications of word sense disambiguation. Word sense disambiguation plays a crucial role as an intermediate task in many natural language processing applications. In machine translation, WST is essential to ensure that words with multiple meanings are accurately translated according to their context, as incorrect translation can lead to miscommunication. In sentiment analysis, WST helps identify whether a sentence expresses a positive or negative sentiment by clarifying ambiguous words. Similarly, in information extraction and text mining, WST improves the precision of system by helping differentiate between similar terms. This is critical in information retrieval. WST resolves word ambiguity in queries, enhancing the relevant information. This is the overview of the WST approaches. Word sense disambiguation approaches are mainly classified into knowledge-based and machine learning-based methods. Machine learning approaches include supervised, unsupervised, and semi-supervised techniques. The four main approaches have unique characteristics that influence their effectiveness depending on the availability of the data and resources. Knowledge-based techniques use external resources like WordNet or WordSenses, making them ideal for low resource settings. However, their performance depends on the quality of these resources. Supervised techniques are highly accurate but require large labeled data sets. They work well in high resource environments but are impractical where data is scarce. Unsupervised techniques cluster words based on context without needing label data, making them useful for annotated corpora. However, their accuracy is generally lower. Semi-supervised techniques combine labeled and unlabeled data, reducing the needs for extensive annotation. They balance accuracy and scalability but require an initial labeled dataset. In short, knowledge-based methods work with external resources. Supervised methods need labeled data. Unsupervised methods handle large annotated data. And semi-supervised methods mix both for efficiency. This is the literature review that I have done. This table presents a chronological summary of major research contribution in the field of word sense disambiguation, highlighting the evolution of techniques from early theoretical foundation to modern deep learning approaches, with a special focus on Hindi WST. The table begins with foundational work in English, such as Gibbs' law of meaning in 1949.
Okay, I guess our current presenter is facing some technical issues, so I would like to call upon the next presenter. Vanashri Pabalkar ma'am to present her paper titled An Interpretable Machine Learning Approach to Fake News Detection and Domain-Wise Classification. Ma'am, are you present? Okay, I guess ma'am isn't present. We can move forward to our next presenter. Shubhangi Gulhane ma'am to present her paper titled Detection of Thyroid Disease Using Deep Learning, a Systematic Review. Ma'am, are you present? Okay, we can just move on to our next presenter if ma'am isn't present. Our next presenter is Spandana Arisepogu ma'am to present her paper titled Explainable Artificial Intelligence Driven Pharmacovigilance Framework for Improving Patient Safety. Ma'am, are you present? Hello, ma'am. I guess ma'am isn't present either. We can move forward to our next presenter. Um, Arjita Jain ma'am to present her paper titled Generation Z and the Sustainable Paradigm Shift, a perceptual study of personal and organizational values in Mumbai's HEIs. Ma'am, are you present?
Yes, ma'am. Very good afternoon. Please allow
Good
me to
afternoon, ma'am.
share my PowerPoint presentation.
You can share your presentation and start presenting now.
Okay, ma'am. Just give me 1 second.
Yes, ma'am, sure.
Is my screen visible to everyone?
Yes, ma'am, it's visible. You may start.
Yeah. Uh, Good afternoon, everyone. And thank you so much for inviting us and to present our paper on behalf of all my co-authors, Dr. Sandeep, Dr. Kiran, Dr. Mankar, Dr. Shushma, and Dr. Pooja Thara. I'm here to present our research paper. The title of our paper is Generation Z and Sustainable Paradigm Shift, a perceptual study of personal and organizational values in Mumbai higher education institutes. This is the flow of my presentation. So, nutshell, we are going to talk about personal and organizational values with respect to Gen Zs in higher education institutes in Mumbai. Talking about Indian culture, in the entire world, India is known as world's richest culture. And the most important element of any culture is the values. Talking about values are the basic intent of an individual that what is right or wrong. And these are basically the moral values which guide human behavior. Often there is a critique with respect to Gen Zs that due to over-reliance on technology or social media, Gen Zs lack in traditional values. And if I talk, this was the point where we thought we must, this is not the research findings, what I'm going to present. And another important perspective when we talk about organizational perspective, employee retention, harmony between the employee and the attainment of organizational goals, very important element is that personal values must align with organizational values. So mainly, this research study focuses on identifying Gen Z's personal and organizational values, and mainly we have focused on four main values, naming them personal values, social values, civic, and work ethic values. Objective of our study is to understand the value system of Gen Z's who are studying in higher education institutes in Mumbai. What are with respect to their family values, social values, work related values, as well as the political or government, which can also say civic values. Based on these four values, we have framed hypothesis, null and alternate, wherein we are trying to see is there a significant relationship between these value parameters with respect to age, gender, education level, or education stream, or there is no significant relationship between these value parameter with respect to age, gender, and educational stream, which I'm going to unveil in the coming slides. Talking about the research design, as I've already spoken, we are trying to understand the personal and organizational values of Gen Zs. The key dimensions of the study is the personal values, social values, civic and work ethic values. Research design is mixed method approach wherein we have used qualitative and quantitative methods. Majorly, this is a quantitative study. Qualitative data has been collected through extensive literature review, wherein we have referred various articles, research papers from various databases, naming JIEEE, your Springer, ProQuest, etc. And the sample size for this research study was 503 students, wherein the respondents were mainly age group of 18 to 25 plus. There were three main groups which we made, and these respondents were undergraduate and postgraduate students. The geographical domain of our study was Mumbai, Navi Mumbai. With a structured questionnaire using online survey, data was collected. And for analyzing this data, we have used SPSS. Cronbach alpha was used to measure the reliability of various constructs. We have used descriptive statistics for for profiling of the respondent, and for testing the hypothesis, we have used various statistical tests, t-test, ANOVA, factor analysis, which I'm going to explain in the coming slides. As I've already shared, in order to check the reliability of the constructs, as you can see in the table, the Cronbach alpha value is more than 0.7, which shows that all constructs were very reliable. In the factor analysis, the tables which we have presented in our paper, I'm just, as we have the limitation of time, I am presenting my findings pertaining to every hypothesis. Talking about the first hypothesis, wherein very interesting findings you will come to know with respect to gender, the significance value came 0.05, wherein it indicates that we need to reject null hypothesis. Now, what does it reveal? When we talk about work values or work ethic values, there was a statistical significant difference how the work values are being perceived by male student or female students in Mumbai. The findings reveal that male students prefer the organization which give them more autonomy over higher pay. Talking about the education level, wherein the significant value, which is visible on the slide, came as 0.91. Again, it was higher than 0.05. And it shows there is no significant difference in the work value perception across education level. Talking about the social values and educational stream, wherein again, as the significance value was 0.0018, here it is below 0.05 value. H0 was rejected, and what it reveals that there is a significant difference in the social values perception depending upon the educational stream. The findings reveal that the engineering and medical students gave higher rating when it comes to social values as compared to management law or IT students. As far as age is considered, again, that there we need to reject H0. It reveals that there is no significant difference in how social values are perceived with respect to different age groups. Talking about the testing of second hypothesis, wherein what it reveals that depending upon the educational stream, there is no appreciable difference in the work ethic values, how these work ethic values are perceived. Wherein the work ethic values, perception of work ethic values is not at all changing with respect to various age groups. Moving ahead, when we talk about testing of hypothesis 3, the findings reveal that the significant value came 0.868 higher than our 0.05. Again, we accept H0. What it reveals that due to educational stream, there are no appreciable differences in how family values are seen when we talk about graduate or postgraduate students. Similarly, we conclude that due to age group, there is no visible variation in how family values are perceived. Sorry. Talking about the testing of hypothesis 4, wherein it reveals that there is no observable variation in how civic values are perceived. When we talk about civic values and the education level, there is no observable variation in how civic or political values are being perceived. Talking about civic values and educational stream, again, it was found that there is no observable difference in how civic values are being perceived by these Gen Zs.
Excuse me, ma'am.
Yes, ma'am.
Ma'am, your 9 minutes mark is over, so can you
Okay.
please speed up your presentation? You have about 1 more minute left.
Okay, ma'am. Sorry, sir. I'll speed it up. So, moving ahead with the observations, see, wherein we talk about Gen Zs and traditional values, and my findings, wherein they are more aware about their personal and social values. The majority of the students, they credit their parents for their personal development. They believe in God. They are helping their parents in household work. They support women and child's right. They are talking about equality, voting, and summarizing the overall insights that social values are not influenced by gender, education level, age, but differ by stream of education, as we have seen in the case of engineering and medical students. Now, talking about the limitation, scope, and research implication, as I've already said, only 503 students participated. Mainly, it was quantitative study. The biggest limitation can be if we can extend the sample size and the different parts of India. This study can be carried out. We can do a comparative study of Gen Zs from town and villages, and definitely more qualitative data extension interviews, focus group presentation will add value, can add value to this particular research, taking it to the next level. Concluding my presentation, I would like to say the study examined the students value system on 4 dimension, which I've already spoke about. Now, important part is we have seen that social values were strongest for gender equality, civic values for the importance of voting, youth responsibility in politics, and work ethic values for work-life balance. And it was found that Gen Zs pay strong emphasis on family support, equality, and the most important thing is they are looking for flexibility, inclusion, they prefer sustainability, and how their values can be aligned with the organizational values. That this would be the biggest implication, wherein this study underscored the importance of value alignment between the employer and employer, which will result into higher retention, job stability, and this will definitely help HR executives to design their policies uh, so that the Gen Z's value system can be taken care. And these are my references, and I'm open for discussion. Thank you for giving me this opportunity. Over to you, ma'am.
Archana, ma'am, do you have any questions?
No questions. You can proceed.
Okay,
Thank
ma'am.
you.
Thank you for
Thank you.
presenting, ma'am. I would
Thank
like
you.
to call upon our next presenter,
Thank you.
Vedika Jorika, ma'am, to present her paper titled HiPySim, a permission blockchain simulator with execute order validate pipeline. Over to you, ma'am.
Yeah, good afternoon, everyone. So I would like to present and myself, Vedika, and ma'am, whether my screen is visible? Yeah, whether my screen is visible, ma'am?
Ma'am, it's not visible yet.
Yeah, okay. Ma'am, what about now?
Yes, ma'am, it's visible. You can start.
Yeah, okay. And myself, Vedika, and I'm assistant professor from Sumati Reddy Institute of Technology for Women from Warangal. And I would like to present on 10th International Conference on Smart Trends in Computing and Communication. And I would like to present my paper that is like research article on HiPySim, a permission blockchain simulator, execute order and validate pipeline. So these are the contents like which includes abstract introduction, objectives, literature survey, HiPySim architecture, and results and discussions and conclusion along with the references. So nowadays, like wherever blockchain technology has been becoming increasing importance across the industries. Actually, it has been started in the financial sector, but later on, due to its characteristics, immutability, transparent, and so on. So this particular blockchain has been implementing in wide variety of the different types of domains, and actually, many blockchain simulation frameworks are available. But in order to develop, like in order to implement or test our particular application on a blockchain network, it takes like the infrastructure costs are very high. Why? Because due to its complex networks and their characteristics. So in order to overcome that, we have developed a private blockchain. Already we have blockchain that is nothing but like private blockchain hyperledger, which allows like modular structure, which we are going to have something like pluggable components where we can have like consensus mechanism in a separate way and like endorsing nodes. So these all are can be modular structure. So by using that, we have developed a private blockchain which mimics little bit similar to the hyperledger fabric, and the name of that blockchain is Hypers. And this replicates actual blockchain operations. And why we have done this? Because we could not implement or we could not deploy our application in that particular blockchain network, which is private. So basically, in 2008 itself, this introduced by Nakamoto, and where it was only belongs to financial, but later on, due to the backbone technology of blockchain, it has been implemented in wide. And blockchain is nothing but a ledger replicated, which is across nodes in a blockchain network, and all the transactions are transparent and committed in a blockchain network, and there is no something like centralized. All the nodes are trustworthy and all the data is stored which is of transparent. So in the blockchain we have two types. One is public blockchain, other one is a private. So public blockchain is nothing but it is of permissionless blockchain, and private blockchain is nothing but like permission. So in permissionless blockchain, any of the nodes can be added into the network without any permission. The thing is it should solve some puzzle or something like consensus in order to add into the network. In the same way, private blockchain is there. Private blockchain is nothing but like permissioned black blockchain. So the authority is going to be checked, and only authorized nodes are going to be added into this particular private blockchain.
So these are the main objectives of our research article. We have developed a modular permission blockchain simulator, which is called like HyperSim, to simulate same as like similar to Hyperledger blockchain network. And we have developed Raft and PBFT pluggable algorithms, which are used to validate and evaluate the consensus and the performance of using the IoT use case. Actually, this research article, we have focused on IoT use case. These are the different types of simulators which are available in the market. Some are like consensus protocol, some are permission, some are permissionless blockchain simulators. And this is BlockSim, Bcella, Simba, BlockPerf, BFT Sim, Bcube Chain. So these all support some, they have some limitations where no endorsement mechanism, missing permission support, and does not support like permission blockchain architecture. So these all are the different types of uh, available blockchain simulators and with their different limitations. So that's the main thing. The key challenges are as we could not deploy or as we could not test our uh, domain or something like our application onto the blockchain, we have developed a private blockchain that is nothing but Hyperson. And with this is nothing but discrete event simulation model, which is going to collect all the timestamps like a time event timestamps, and each and everything is going to be noted down, and based on that all the transactions are going to be saved. So this is the main architecture, how the HyperSim is going to like how the transaction flow and how it is going to be collected. So as I have said that this is a discrete event blockchain simulator, which is designed to study permission blockchain. This simulator consists of 5 different components. One is transaction generator, endorsing node, ordering node, committing node, ledger model. So as our use case is IoT, the first one is the transaction generator. From this transaction generator, all the transactions which are generated from different IoT daemons are going to be collected here. After collecting those transactions, along with the timestamp, along with the payload, all these are going to be sent to the endorsing peer. So this endorsing peer, it is going to check for the transaction validity. So this validity, and it is going to verify whether it is like digitally correct. And this endorsing is done by using smart contracts. Smart contracts has nothing but the like different types of rules and regulations what to be executed on these particular transactions based on our domain or something like based on our use case. Once all these are verified, these are given back to the transaction generator. Once this transaction generator receives, then it sends all the transactions along with the validation and timestamp to the ordering service. This ordering service, it does not execute anything. Just it is going to order in a particular predefined manner. So once it is ordered in a particular manner, then this is given to the committing node where all the transactions till now we were talking about only the transactions, but now all these transactions are converted into the blocks where these blocks are added to the blockchain. So here, according to this diagram, there's the transaction generator, endorsing PR, ordering service, committing PR, ledger, word state, and this is the sequence diagram of transaction flow of matrices collection of HyperSim. So results and discussion. Already Hyperledger has been implemented by using Raft and PBFT as per the consensus. So we have done this with the 4 different algorithms, consensus algorithms. One is for the fabric, like Raft, and PBFT, hot stuff, and tendermint algorithm. So which shows something like a 5% improvement when compared with the other algorithms. So I want to conclude my paper. Like initially blockchain was pertinent to financial domain, but later it was moved to the each and every technical and non-technical sectors like academics and even like education, health sector, IoT, and everywhere. And this results or this work presents a discrete event simulator which reproduce the fabric, execute, order, and validate transaction flow. And we have taken or compared the like values of hyperledger caliper benchmarks with of less than 5% of deviation keymarks. And here we have used even hot stuff consensus algorithm in our HiPySim, so that we have like a little bit like 22% of improvement were there. And so this could be a valid simulator, private blockchain simulator, where we can test our application or implementation of a blockchain. And these are the references. Thank you, ma'am, for giving this opportunity.
Thank you for your presentation. Archana ma'am, do you have any questions?
No, no presentation. Well presented.
Okay. Thank you,
Thank you,
ma'am.
ma'am.
Yeah.
I would like to call upon our next presenter, Vinto ma'am, to present her research paper, A Comprehensive Analysis of Pre-Processing Strategies for Hindi Word Sense Disambiguation.
Ma'am, should I start from beginning or I can start from the literature review?
You can start from literature review.
Okay, thank you, ma'am. Thank you so much. Is my screen visible?
Yes, ma'am, it's visible.
The table presents a chronological summary of major research contributions in the field of word sense disambiguation, highlighting the evolution of techniques from early theoretical foundation to modern deep learning approaches with a special focus on Hindi WST. The table begins with foundational work in English, such as Jeff's Law of Meaning in 1949, which established the relationship between word frequency and polysemy and laid the theoretical groundwork for WST. This was followed by Wick's Preferences Semantics in 1975, an early knowledge-based approach using selectional restrictions. The first computational solution appeared in 1986 with the LESC algorithm, which used dictionary definition overlap, later enhanced in 2003 through the extended LESC method by incorporating WordNet semantic relations. From 2004 onwards, the focus shifts significantly toward Hindi WSD. Early efforts relied on knowledge-based methods using Hindi WordNet, achieving moderate accuracy, but remaining limited mainly due to noun disambiguation. As research progressed, unsupervised and supervised machine learning techniques were introduced, including decision list, naive-Bayes classifiers, and cosine similarity-based methods. These approaches demonstrated that incorporating morphologically features and contextual information is particularly important for Hindi due to its rich inflectional structure. Later studies explored advanced representations such as word embeddings, clustering, and graph-based random walk methods, which allowed the use of large unlabeled corpora and improved scalability. Optimization techniques like genetic algorithm further enhance performance by effectively selecting optimal senses. Most recently, deep learning approaches using BILSTM combined with word-to-vec or fast text embeddings have been applied to Hindi WST, addressing resource scarcity and achieving competitive F1 scores. Overall, the table clearly shows a progression from rule-based and knowledge-driven approaches to data-driven and neural models, reflecting both technological advancements and increasing adaptability to low-resource languages like Hindi. This is the proposed WST methodology. First of all, the Hindi sentence is given as input. After that, pre-processing is performed. After that, pre-processing is performed. On the input string, various pre-processing steps include stop word removal, tokenization, lemmatization, stemming, and Pierce tagging. After pre-processing, an algorithm is applied to perform sense disambiguation of the word. The various types of algorithms are knowledge-based, supervised, and unsupervised algorithms. This is the pre-processing steps that have been applied on the input string. First of all, tokenization. Tokenization is the process of breaking down text into smaller parts, such as words or sentences, known as tokens. This is the output that we achieved after tokenization. Next is stop word removal. Stop word removal is the process of removing frequent words from a piece of writing, such as the, is, and. These words are frequently regarded as non-informative and can be safely removed without altering the sense of the text. The next step is lemmatization. It is the process of reducing words to their base or root forms, also known as lemma, in order to normalize variants of the same term. Unlike stemming, which removes prefixes and suffixes without regard for the word's meaning, lemmatization takes into account the word's context and morphological structure in order to generate valid lemmas. The next step is the part of speech tagging. Pure tagging assigns grammatical categories such as noun, verb, adjectives, and so on to each word in a sentence, depending on its context and role in the sentence. This is the WordNet that we have used. WordNet plays an important role in WSD by providing structured semantic information. Instead of treating words independently, it groups relating meaning into syntax, which helps system identify the correct sense of a word based on context. For our work, we have used Hindi WordNet, which is specifically designed for the Hindi language. Since Hindi has rich morphology and limited annotated resources, Hindi WordNet provides valuable semantic knowledge that supports effective word sense disambiguation. This is the part of the Hindi WordNet. Hindi WordNet contains synset or the gloss. The synset is a group of words with similar meanings, like for example, pen, kalam, lekni represent a single word, and the gloss is the definition and the example of the example sentence. Experimentation. The aim of the experiment is to examine and analyze the impact of various pre-processing techniques on Hindi WSD. A standard data set have been compiled and systematically analyzed for this purpose. We have used the Google Colab platform, and the programming language is used Python, and we have used the sample data set from the TDIL. This is the data set that we have used. Base the main data set contains 60 ambiguous Hindi nouns, but we have used 6 nouns from them. Each nouns contain these number of senses, and the number of instances of the words have been given in the table. The feature extraction technique that has been used in this work is TF-IDF. TF-IDF is used for feature extraction to convert textual data into numerical form. Term frequency captures how important a word is within a document, while inverse document frequency reduces the impact of words that appear frequently across many documents. By combining both, TF-IDF highlights rare but meaningful words that are useful with distinguishing word senses due to its proven effectiveness in text classification and NLP tasks. These are the results with pre-processing. So these are the results without pre-processing, and these are the results with pre-processing. In this experiment, 6 machine learning classifiers, SVM, naive-bayes, neural network, decision tree, random forest, and logistic regression were evaluated on a manually annotated Hindi WSD dataset without applying any pre-processing techniques. 6 ambiguous Hindi words, namely hal, har, jet, kum, uttar, and kalam, were disambiguated using a context window that included surrounding words, as shown in table 2. Most classifiers achieve only moderate accuracy in the absence of pre-processing. This is mainly due to the morphologically rich nature of Hindi, which introduces noise, inflectional variations, and redundant contextual features. The resulting TF-IDF vectors become sparse and Hindi high-dimensional. Neural networks and logistic regression perform relatively better in this condition, as they can learn complex non-linear and linear decision boundaries even in noisy features. This table presents results with pre-processing. The classification result after applying pre-processing techniques such as tokenization, normalization, stop word removal, and feature refinement. These steps significantly improve the quality of contextual information by reducing vocabulary size, minimizing morphological variations, and eliminating irrelevant features. As a result, classifiers such as SVM, near-base, and logistic regression show clear and consistent improvement in accuracy. The group bar chart illustrates the impact of preprocessing on different classifiers for Hindi WST. From a methodological standpoint, these results directly verify the suggested Hindi WST framework, which uses TF-IDF representation for supervised classification after contextual feature extension. The findings highlight how crucial preprocessing is to Hindi WST, especially when it comes to managing morphological richness and data sparsity. This is the conclusion. The work studies the impact of preprocessing on Hindi word sense disambiguation. Techniques like stop word removal, lateralization, and pair tagging reduce noise caused by Hindi rich morphologically and significantly improve classifier performance. Effective preprocessing is not optional but foundational for robust and scalable Hindi word sense disambiguation, especially in low source settings. However, limited annotated data remains a key challenge, and future work can benefit from deep learning models such as transformers. These are the references. Thank you so much. Any query?
Archana ma'am, do you have any questions?
No questions.
Okay. Thank you for your presentation. Now I'd
Thank
like to
you.
call upon our next presenter. Supriya Joseph ma'am to present her paper titled Interactive Virtual Reality Based First Aid Training. Over to you, ma'am.
Okay.
क्या रखे नहीं जुड़े रहना पूरे 5 बजे तक
Can you able to see my screen, my presentation?
रुक जा एक
Yes,
देख
ma'am,
लूं
your screen is visible.
Okay. Good afternoon. Myself, Supriya Joseph, PhD research scholar, NIT Trichy. My co-author, Professor Dr. M. Sridevi. My topic is interactive virtual reality based first aid training. Okay, these are the contents of my topic: introduction, motivation, literature review, research gap, proposed methodology, research conclusion, and references. So, coming to the introduction part, first aid is the as per the WHO, first aid is defined as the initial care provided to a person who has been injured uh, or got ill unexpectedly before professional medical assistance arrives. And the care cannot be taken unless the people are aware and trained in first aid. So, this research work proposes a virtual reality based first aid training for the people to make them aware of how to manage emergency situations. It will help them practice first aid scenarios and perform first aid on some victims by watching the videos using VR headset. VR technology, which provides an immersive experience for people, is best suited for education and training. And the motivation for this paper is to improve the training through the realistic simulations, enable personalized and precise and enhanced monitoring for optimized health and performance outcomes. And the second one is to achieve the better preparedness, reduce risk during procedures, and effective recovery plans, and ultimately ultimately improve patient outcomes and personalized care. These are the some purpose I referred for the literature review. And the research gap I have noted down from the literature review is the limited digital infrastructure creation and the inefficient quality and non-availability of the model. It does not consider all the use cases and the limited degree of freedom or interaction. The problem statement is to develop a first aid and CPR training system using immersive technology and AI to provide proper guidance for trainees. The issues addressed are the interaction between virtual and the real world, blood flow and wound depth of first aid, for the first aid. The technology I have used for the immersive environment, I have used Blender and Unity. The objective is to provide easy interaction with the virtual space and to provide experiential learning for the better understanding. This is a block diagram of the proposed system. So there will be a user that can be a trainee or student, and he will be having a VR headset with the both the right and left hand controllers. And this training will be he will experience the training based on some scenario, like some procedures will be there. Based on that, he can watch like the videos of how the performance is doing. He can watch through the VR headset, and based on that, he can test it on some training some victim. And here in this scenario module, I have included the cases like wound and injuries, burns, fainting, CPR, and call ambulance. For each of these procedures, there will be a manual or some steps to follow. Like suppose I am selecting some wound and injury, so there will be a steps, initial steps or lesson will be there to how to take care of the cases of wound and injuries. And then after that, there will be a video demonstrating that wound and injuries, how to take care of the wound and injuries. The same manner for each of the cases, each of the scenarios, there will be a corresponding uh, steps to follow and the corresponding video. The design I have done for Blender, I have used for creating some 3D model, and Unity, it enables the real-time training simulation of the created patient with the different scenarios. And MetaQuest headset used, it provides the immersive interaction for training for the different first aid scenarios and CPRs. So these are the part of some results. The initial we can select the choice, like which one we want to select. The trainee can select the choice. And these are the results that comes from the taking care of the wounds and injuries, the screenshots for the entire scenario. So the first one is a person with a wound on the left leg, it is. And the next step is one first aid box is kept near the person, and there is a band-aid, and using the ray interactor of the metahertz, the person is trying to take the bandage and pointing that bandage to the corresponding person's wound and placing the bandage onto the wound. And the last one is checking the response of the person. And these are the screenshots for the performing CPR. So there are two cases, like one is rescue breath and the other one is chest compression. So this is a sample video of performing the CPR. So there is a option like a CPR, and the corresponding the steps to follow also will be there. And based on the person can do the procedure of CPR. Now conclusion. The study presented a VR application for demonstrating the first aid for the people, and the system explained procedures for the use cases like wound and injury, burns, fainting, CPR, and calling an ambulance. The video designed by creating scenes in Unity, which can be integrated with the Oculus MetaQuest headset. The code for navigating through the scenes and for performing the various procedures, I have used C# code. In the future work, the system will expand to include the other procedures to make it a full-fledged VR simulation with a responsive feedback system. These are some of the references. Thank you. Excuse me, ma'am, any queries?
Archana ma'am, do you have any questions?
Oh, no queries. Can continue.
Okay, ma'am. Thank you, ma'am. Thank you for your presentation, ma'am. Now I'd like to call upon our next presenter, Shivkarthik S. Sir, to present his paper titled Robust Multilingual Language Identification with Romanized Script Detection Using LLMs and RAG. Over to you, sir. Are you present?
Yeah, hello, good afternoon. Am I audible?
Yes, you're audible. You
Ye-
can share the screen and start presenting.
Okay. Hello. Good afternoon, everyone. I am Satyam Mishra, and this work is joint effort with my co-authors Prajakta Dange, Sant Shiva Karthik S, and Swati Mehta from CDAC Pune. Today, I will be presenting our work on robust multilingual language identification, especially focusing on Romanized text using large language models and RAG, Retrieval Augmented Generation. We are presenting this work at SMARTCOM 2026, and the motivation for this research comes from a real world growing challenge, that is language identification in multilingual, noisy, romanized text, especially in Indian low source language settings. So this is our table of content. In this presentation, I will briefly walk you through the problem motivation, our proposed LLM plus RAG approach, the dataset and architecture, followed by experimental results, analysis, and future directions. So our core idea is to jointly identify both language and script, native or romanized, using a retrieval augmented LLM framework. Instead of relying only on classifiers, we retrieve similar examples from a multilingual database and use them as a context for the LLM, which helps especially with short, noisy, romanized text. Quick example if we take is like kaise ho, written in English like we have in our WhatsApp chats, but it is actually a sentence of Hindi. So this type of language is known as romanized Hindi. And why this matters is this directly improves a real world NLP pipeline such as content moderation used in hate speech, spam, etc. For various machine learning models like translation, transliteration, we actually need a basic language to identify, and multilingual analytics on social media. From our approach, we have 15 points increase in our F1 score on romanized text compared to strong baselines. The gains are highest for low resource languages like Bodo and Manipuri, which are typically underrepresented. This makes our system highly useful for real world NLP pipelines like translation, moderation, and analytics. So, language identification or LID works well in clean native scripted text, but becomes extremely difficult in multilingual and cross-script environments, which includes many languages in a single sentence. It fails badly in real-world conditions. In formal romanization, native languages are typed in Latin script. Spelling variations, these are the scenarios in which the traditional models fails, like in formal romanization, spelling variation, spelling is inconsistent, code mixed inputs, users mix languages such as Hindi and English in a single sentence. For example, तुम ऑफिस आ रहे हो क्या? So office is English word and the whole sentence is written in Hindi. So it has to be detected as romanized Hindi, but the traditional language models represent it as a English. So there our future pipelines will also fail. For example, the same Hindi sentence may appear as there are spelling variations like कैसे हो में कैसे की spelling KAISE, KASI, or KAISEH. So these are the different variations of कैसे हो का कैसे हो words. In this, our traditional models get failed because it cannot identify the difference between all. So traditional classifiers struggle because there is no fixed orthography in Romanized text. This leads to confusion. For example, Romanized Hindi versus Romanized Urdu, which share vocabulary. Prior work includes classical models like fast text and n-grams, which fail on noisy inputs. Fast text that is developed by Meta AI fails on short and romanized text. Indic LID, a strong baseline model, but weaker on informal romanized text and misspelled words. Further, some LLMs work are also done like Roman Setu and Roman Lens, which explore romanization inside LLMs, but its major drawback is that it fails if the multiple languages are mixed in between the sentence. So the persistent gap is that most systems do not jointly model language and script. But in our framework, we have used both the language plus its script, so to get a better output compared to the traditional models. So it is our data which we have collected from different sources. We performed rigorous pre-processing, including noise removal, script labeling, spelling normalization, and strategic resampling. This ensures balanced learning across high and low resource languages. This table shows the scale and diversity of a data set. Languages like Hindi, Tamil, Marathi have both native and Romanized samples, while low resource languages still receive significant coverage like Bodo and Santhali. So we have collected a vast data set for this. Our system work in two phases like offline ingestion and indexing and real-time identification. Text is embedded, retrieved using ANN search and passed to the LLM along with similar examples for the final prediction. We use hybrid tokenization for noise, fast text and transformer embeddings, vector databases like Milvus, LangChain for orchestration. This modular design makes system scalable and flexible. So this is the prompt, this is the code snippet, like we have attached the prompt to our LLMs for generating the better response. So prompting plays a key role. We use different type of promptings like few short examples, retrieved similar samples, prompt assembling. Example, if your input is tum kem cho acho, retrieved examples helps the LLM correctly identify it as a Romanized Bengali, not Hindi. So if you talk to your LLM like similar, giving the similar example from the databases, so it can perform better rather than the traditional training of the LLM itself. So the RAG plus LLM architecture is very useful for the better response generation. We evaluated across GPT-4, GPT 3.5, Llama 2, Mistral, in which we have performed zero shot learnings, few short learnings. Zero shot learning performs tasks with no example, relying solely on pre-trained knowledge and instructions. While few short learning provides a small handful, 1 to 5 examples within the prompt. So in our previous slide, we have given the few prompts to our LLM so that it can understand it better. Baselines like Polyglot, Indic LID, and FastText. These are the traditional models, but they fail on the Romanized contents. So we have moved to LLMs plus RAG framework, and we have calculated the scores based on the F1 score, accuracy, precision, recall, and confusion matrices. So the result clearly show that for the native language script, we have gain smaller than the Romanized language script, because for native language script, some models are present already and they are giving good results. But on top of it, we have improved our results by some percentage. But on Romanized, we have significantly improved our results, because traditional models are very few compared to the LLM plus RAG network. The results clearly show 12 to 15% improvement on Romanized text, 98.2 accuracy for native Hindi, 15.4% gain for Bodo, a low resource language. So low resource language are where the dataset is rarely present, or we have less number of speakers for the same language. So this confirms the effectiveness of our LLM plus RAG approach. The major failure cases for the models are like very short inputs. If we given a input sentence which consists of less than 3 words, then these are considered to be very short input. So basically models cannot identify the context of the language given to it, so it fails there. And spelling variations, like we have decided kaise ho ki spelling can be different in many instances, so model does not identify it as a single thing. And code mixing, in which a single sentence where are multiple languages are present, so models get hallucinated that which language it had to return. So however, RAG resolve around 40% of ambiguous cases, especially for Hindi Urdu confusion.
Minute left.
Yeah, I'm speeding up. Yeah, key strengths of our model is its robustness to the noise data, strong low resource performance, modular design. Trade-offs include higher interference cost, but the accuracy gains justify it for critical applications. It is slightly the cost of these models are higher, but accuracy wise, it's beat all the traditional models. So we will also in the future trying to get our models for the low cost or low supply models. And in conclusion, we present a robust retrieval augmented LLM framework that effectively handles romanized, multilingual, and low resource language identification, bridging a critical real world gap. So, for the future, we are trying to cover more languages. Like currently, we are supporting for 22 languages. We are trying to add more languages and informal model learning, enhancing robust against dynamic internet slang, phonetic type variation, like we chat on the WhatsApp, like we talk on the phones. So we will also try to include phonetic type variations and non-standard orthography. For the latent signal, exploiting internal activity activation layers of LLM detect implicit romanization signals without explicit prompting. Like we have does not have to specify more and more prompts for getting the better output. And efficiency optimization, distilling the RAG LLM pipeline into lightweight student models for cost effective, low latency and deployment. Thank you very much for giving me the opportunity to present myself.
Thank you for your presentation. Ma'am, do you have any questions?
No. Good work. Very intense work. Good.
Okay. I would now like to call upon our next presenter, Shubhangi Gulhane ma'am, to present her paper titled Detection of Thyroid Disease Using Deep Learning, a Systematic Review. Over to you, ma'am.
Yes, ma'am. Shown there?
Yes, ma'am, it's visible. You can start presenting.
Okay, ma'am. Yes, ma'am. Is it visible? My PPT is visible?
Yes, ma'am, it's visible. You can start.
Okay, ma'am. Good afternoon, everyone. I am Shubhangi Gulhane, PhD scholar, Ramdev Baba University. Today, I will be presenting paper on the topic Detection of Thyroid Disease Using Deep Learning, a Systematic Literature Review. These are the contents. Thyroid disease are among the most common disorder related to the endocrine system, and it affects a large number of people across the world. One very important point is that women are affected 10 times much more than men. Conditions such as autoimmune thyroid disease, thyroid problem during pregnancy, and even thyroid cancer are found more frequently in women. Thyroid disorders do not affect only the thyroid gland, they influence the whole body, including metabolism, reproductive health, and even mental well being. Patients often experience symptoms like fatigue, weight changes, mood swings, and fertility related issues. Because these symptoms are often common and easily ignored, early and accurate diagnosis becomes extremely important. Traditionally, thyroid disease is diagnosed using blood test, ultrasound imaging, and in some cases, fine needle aspiration biopsy. These methods have several limitations. They can be subjective, invasive, and often do not support personalized diagnosis. With the rapid growth of artificial intelligence in healthcare, machine learning and deep learning methods are being increasingly applied. There is still a lack of structured review that summarize deep learning approaches significantly for thyroid disease detection. This gap motivates us to conduct a systematic literature review. Now, what is the role of deep learning in thyroid diagnosis? Deep learning has emerged as a powerful tool in the diagnosis of thyroid disease. One main advantage of deep learning is that it can automatically learn important features from medical data without relying only on manual interpretation. In thyroid diagnosis, deep learning is especially useful for analyzing ultrasound images. Apart from the images, deep learning model can also work with clinical and hormonal data such as TSH, T3, T4 levels. By combining this information, the model handles complex and non-linear relationship between different parameters. Overall, deep learning improves diagnostic accuracy and reliability, and it supports clinicians in making better and faster decisions. Now, this is the systematic review methodology. For this systematic review, we search multiple well-known scientific database, including PubMed, IEEE Explorer, then Scopus, Web of Science, as well as Google Scholar. Then we consider some paper for conference, some conference paper published between 2015 to 2024. Only studies that use deep learning technique on medical thyroid data were included. Next, now the first stage is identification. In this stage, we search multiple well-known database to collect relevant studies. Total 742 records were initially identified. These included from IEEE Explorer, there are 214 papers, then 187 from Scopus, 98 from Web of Science, and 87 from Google Scholar. After collecting the records, we remove the duplicate entries that appeared in more than one database. After duplicate removal, 628 unique records remain for further analysis. In the screening stage, we review the title and abstracts of 628 records. At this point, the studies that were not relevant to thyroid disease focus only traditional machine learning or non-medical data. The remaining 157 articles were then assessed in full text to determine their eligibility. Out of these, 116 full text articles were excluded. Reason of exclusion is absence of deep learning methods, poor methodology used. Finally, 41 studies were selected for inclusion in the final analysis. This is the overview of reviewed literature. Then these are the table. This table highlights some important studies on machine learning based on thyroid disease. Different methods such as SVM, random forest, XGBoost, neural network, and ensemble models were used on clinical data and standard dataset like UCI thyroid dataset, that is the public dataset. Most studies reported high accuracy and showed that ensemble and advanced model can improve prediction and support early diagnosis. Common limitations include limited explainability, evaluation instability, dataset bias, and lack of multimodal data. Now the second table, this compares different image-based method used for thyroid disease diagnosis. Some studies use non-invasive ultrasound images with machine learning model like random forest and achieved good accuracy, while other relied on invasive images with moderate performance. More advanced approaches such as deep learning and ensemble models showed higher accuracy and diagnostic efficiency. Now the next table shows that machine learning and deep learning model perform well for thyroid diagnosis across different data types. Deep learning model, especially those using ultrasound or combinational clinical data, achieved high accuracy as well as AUC value. Overall, the result highlight that using richer and multimodal data can improve diagnostic performance. Now, next is trend and observation. From the review studies, several important trends are there. There is a growing shift from conventional machine learning to deep learning models. Techniques such as transfer learning, ensemble learning, and data balancing methods like SMART increasingly used. The use of multimodal data and explainable AI technique is still limited, indicating clear opportunities for future research. Now, next is limitation identified. Despite promising results, several limitations are present in existing studies. Most data sets are collected from single hospital or a specific region, which may limit model generalization. There is also gender imbalance, as most data sets are dominated by female patients. Additionally, demographic and hormonal details are often missing, and external clinical validation is rarely performed. Now, this is the conceptual framework. Based on the insight from the systematic review, we propose a conceptual framework that integrates multimodal data. It includes ultrasound images, clinical and hormonal data, genetic information, and lifestyle factor. Different AI models are applied to each data type, and the extracted features are fused for prediction. Explainable AI techniques such as GradCam and SharpLine are included to improve transparency and clinical trust. Now, these are some application of the research. Research focus on improving how doctor manage thyroid disorder in women by integrating predictive algorithm into clinical decision support system. Endocrinologist can get guidance tailored to each patient. Deep learning model help to detect thyroid problems faster and more accurately. Then imaging and monitoring becomes more precise, which is especially important during pregnancy as well as menopause. Key biomarkers are used to predict outcomes and plan treatment. Overall, this approach helps optimize treatment, reduce complications, and improve the patient's life quality. Then after that, conclusion, deep learning has shown strong potential for thyroid disease detection and diagnosis. The review studies demonstrate that deep learning models generally outperform traditional machine learning techniques. Challenges such as dataset bias, lack of explainability, and limited clinical validation still remain. This review provide a structured overview of existing research and highlight the future direction for developing a reliable and personalized AI-based thyroid diagnostic system. Thank you. These are some of the references. And thank you. And thanks for giving me the opportunity for presenting my research.
Yes, ma'am. Thank you for your presentation. Ashra, ma'am, do you have any questions? Okay, I guess no questions.
Questions, please continue.
Okay, ma'am. I would like to call upon our next presenter, Spandana Arisepogu, ma'am, to present her paper titled Explainable Artificial Intelligence Driven Pharmacovigilance Framework for Improving Patient Safety. Over to you, ma'am.
Good afternoon to everyone. I'm Spandana Arisepogu. I'm from the Anurag University, Hyderabad. I'm going to present my presentation about the explainable AI. Are you able to see my screen?
No, ma'am, your screen isn't visible.
Okay. Now, is it
Yes,
visible?
ma'am, you can. Yes, ma'am, you can
Okay.
continue.
Okay. I'm from Anurag University, Hyderabad. Now I'm going to present my paper on explainable AI driven pharmacovigilance and framework. Coming to the introduction, pharmacovigilance monitors the drug safety throughout the medical lifeline and protect the public health. Uh, Clinical trials alone cannot detect all the diverse adverse drugs effects due to the limited data and patients' diversity. The rapid growth of electronic health reports claims the data and social media makes the manual analysis very difficult. Nowadays, artificial intelligence having a helping helps this technique helps so much for automated adverse drugs detections, and safety signals identification. Than this explainable AI improves the transparency, trust, and clinical decisions making in pharmacovigilance systems. This paper proposed an explainable AI-based pharmacovigilance framework to generate the accurate, interpretable drug safety reports. Continuation to the introduction, these NLPs and the machine learnings are helpful improving the adverse drug detections, and deep learning gives the better accuracy but difficult to interpret. Traditional statistical methods are easier to understand but misses complex patterns like statistical methods and everything. Many explainable models do not clearly explain the patient level risk factors. Current explainable AI methods are limited and not widely used in a practice. Hence, there is no need to have need to for simple, transparent explainable AI-based pharmacovigilance systems. Coming to the related works, NLP related and electronic records and social media, lack of integrated explainable framework, limited related work deployment, and improves the patient safety, trust AI detections, regularity ready documentation, and better knowledge discovery. Coming to the proposed framework, this XAI driven pharmacovigilance framework uses the advanced AI model to analyze the drug safety but for multiple sources, helps the experts to understand both the risk predictions and the explanations. Integrated data from the social media and biomedical literatures and electronic health records, claims, and reporting systems into a secure data takes and applies the speeches recognition and purpose of doctor prescriptions and patient helpline recordings, reduces the noise generated accurate medical transcripts, cleans the enrich and structures the data medications classes and clinical ide- details. And coming to the framework, the purpose of the framework consisting of 5 phases: data integrations and harmonization layers and support pipeline line XAI model and XAI enhancement user interface. This is the a picture base. It's a basic base we are introducing nowadays, and this takes the intake and injection pipeline. To the injection pipeline, it sends to the supported pipeline, and it sends to the XI model, and everything will be segregated, and it has been to the user interface. Next, coming to the results, this system improves the trust, patient safety, and regularity compliance through the clear and explainable drug safety decisions. The framework accurately identify the high allergies risk and explain the contribution factors beyond the simple alerts. The outcome demonstrates whether non-traditional data sources may be successful in cooperate in the data intake and implementation layer. Coming to this, these are the intakes we are taking, and the intakes we are recording the whatever the detection is there, that detection has been changed, and we'll be giving the drugs as per the. Coming to the conclusion, the purpose of the pharmacovigilance framework bridges the complex AI predictions and clinical undertaking by integration explainable AI into the safety workflow. It is accurately identifies the high risk cases while providing a clear, regularity, relevant explanation, improving the patient safety, trust, and effectiveness of AI driven drug safety monitoring. This is about my presentation. Thank you. Hello.
Thank you for your presentation, ma'am. Archana
Thank
ma'am,
you.
do you have any questions?
No questions.
Thank you.
Okay. Thank you, ma'am. Now, I would like to call upon our last presenter for the day, Bhadra S. Pillai, ma'am, to present her paper. Over to you, ma'am. Yes, you're audible.
Okay. So can you see my screen?
Yes, it's visible. You may start.
Okay. So my paper is Advances in Artificial Intelligence for Crop Disease Detection, and it's a review paper. So I'm basically Bhadra S. Pillai from Amrita Vishwavidyapeetham, and my co-authors are R.D.M. Nair, R. Parvati S., and Dr. Jeena Prasad. So coming to this, plant diseases are a major threat to global food security. For instance, we see a 20% yearly reduction in wheat yield due to these infections. So to prevent the spread and minimize loss, we need diagnostic tools that are not just accurate, but also fast and sensitive. Traditional manual inspection is often too slow, which is why AI and deep learning are now revolutionizing how we monitor plant health. So basically, we are classifying the models into machine learning and deep learning from the papers we have taken for the review. So coming to the machine learning part, our review categorizes the detection models into two primary branches, traditional machine learning and deep learning. While traditional models often require manual feature extraction, deep learning architectures can learn these patterns automatically. So support vector machines. These have achieved 0.98 accuracy in maze, but can be sensitive to how features are extracted. Random forest ensembles 86% accuracy when considered among different crops. So it can handle noisy, imbalanced data, but is computationally intensive. Then coming to KHBRF, it's a hybrid model combining random forest with a krill herd optimization. So optimizes parameters using krill foraging and diffusion behavior. It's applied on the plant village dataset. Majorly, the dataset we take here is the plant village dataset for images that have the leaves with spottings and all in that. Then coming to the naive-Bayes classifier, it's a classifier algorithm according to the probability of scaling and fast and effectively large data sets. It's having a 79.6 accuracy, and its accuracy drops when independent assumption is violated. Then coming to decision tree, it's an interpretable model using the CART algorithm, and it's 89.2% accurate, and the F1 score is 89%. So it can handle noisy and missing data. It's able to predict missing data. Then coming to the key nearest neighbors, it's a non-parametric distance-based classifier. So it has 91% accuracy. Then coming to logistic regression, it's a linear interpretable classifier predicting class probabilities. It's 87.6% accurate, 93.2% is an AUC for that. Then coming to AdaptBoost. AdaptBoost is a boosting algorithm which helps in enhancing the weak learners. So strong and clean data sets, prone to overfitting or noisy data, limited scalability and multi-class capability. Then coming to deep learning models, convolutional neural networks, artificial neural networks are the major deep learning models which are being used here. So convolutional neural networks or CNNs are the current state of the art for this field. They automatically extract disease features and have achieved accuracies as high as 98.2%. So we also see sequential models like GRUs being used to learn temporal patterns. So there are specialized architectures like AlexNet and VGG. So AlexNet and VGG, these deep networks utilize transfer learning to reach accuracies between 95 and 97%. Then comes MobileNet. MobileNet is a lightweight model specifically designed for mobile phones, boasting a 97.5% accuracy. The deep learning framework, these detection algorithms can be implemented using a mobile phone as well. Then comes the exception. Currently, this stands as one of the most precise models we reviewed with a 99.1% accuracy. Then comes DenseNet. This uses dense connectivity to improve the flow of information across the network, achieving up to 96.88% accuracy. Then comes the real-time object detection algorithms like YOLO V5. So for field applications, we look to object detection models like YOLO V5. Unlike standard classifiers, these identify the specific diseased regions within an image. YOLO V5 has shown the best overall performance with mean average precision of 97.7%. And then coming to the Inception ResNet V2, it combines the Inception and ResNet models together, getting a strong accuracy of 97% and DenseNet 121/201, it's having an accuracy of 96.88%. So coming to the results and discussion, there's a significant crop loss in this field due to in the fields due to many diseases that are affecting the plants. So despite these impressive number of accuracy and these models, there are significant hurdles to overcome. Developing nations still lose up to 40% of crops annually. Most current AI systems were trained on high quality lab images. Consequently, they can become unreliable when faced with real world issues like poor lighting or busy backgrounds. Furthermore, we face a data scarcity for specific crops like finger millet, which can lead to model overfitting. Then coming to the conclusion. In conclusion, while AI is transforming disease detection, we must focus on accessibility for a country like India, providing these tools via easy-to-use mobile apps in the most effective way to help farmers. Future research should focus on expanding training datasets and creating lightweight models that work reliably in diverse field conditions. Thank you for your time. And these are the references we took basically. Thank you. Any queries?
No queries.
Thank you for your presentation. And Archana ma'am has no queries. Thank you for your presentation.
Okay.
Since we have completed all our presentations for the day, I would like to move towards the closing remarks now.
Okay. So, Gayatri, would you be speaking something?
Yes, ma'am.
Yeah, please go ahead.
So I would like to sincerely thank all our authors for the excellent presentations and contribution in this session, and all our participants for being a part of this international conference. I hope this session was informative enough. We on behalf of we on behalf of the whole team, we thank you for the support during this 10th version and all the previous 9 versions of the conference. We'll be happy to have you in the 11th version in 2027 as well. All the presenters would be getting their digital certificates through mail within 2 working days, and the publication will be live within 7 to 8 months. Kindly cooperate with the team of SMARTCOM 2026. And I would also like to thank our session chair, Dr. Archana Chaudhary ma'am, for chairing this session. Here is a token of appreciation to the chair on behalf of Team SmartCom 2026 and Global Knowledge Research Foundation and partners. Thank you for your valuable presence, ma'am.
Yes, thank you.
And
And
yes, thank you for your
like,
presence, ma'am.
yeah, I would like to give the feedback that
Yes, ma'am.
all the presentations were very good and very elaborate, and many of the research scholars or the participants have done rigorous work and they have presented it. So I congratulate all of them. That's
Thank
all I
you, ma'am.
wanted
Thank
to
you
say.
so much. Yes, thank you for your time, ma'am. Now, before kindly ending this session, I would request you all to switch on your cameras for a quick snapshot of the virtual conference. Can you all please on your cameras? Hello, can you all please on your cameras? Okay, I've taken the screenshot. Now I'll be ending this session. You all may leave the session and stay safe, stay healthy. Thank you for attending.